So quotient rule is a little similar to product rule, which we learned earlier, with respect to the fact that we'll use u and v again, but it's a little different. We have two functions this time, like previously, but this time they're divided in such a manner that they cannot be converted to a single function. Thus, to differentiate, we apply the quotient rule. So we'll take the numerator as u and the denominator as v. So my u is going to be ax plus b and my v is going to be cx plus d. The differential of u is going to be u prime, which is a. The differential of v is going to be v prime, which is going to be c. This is the formula which we'll use for quotient rule, and you can simply substitute the values of u, v, u prime, v prime, and determine our final expression. You must remember this formula if you are to apply quotient rule. Let's take our first example, 3x minus 5 over 2x plus 1. Start by determining u and v. My u is 3x minus 5. My u prime is going to be 3. My v is 2x plus 1. My v prime, that is the differential of v, is going to be 2. Easy peasy lemon squeezy. What? Alright. So, the formula for quotient rule, write that down for reference. That's what I always advise my students to do. And then simply substitute the values. So v is 2x plus 1 and u prime is 3. We have minus sign in between, mind you, in the quotient rule, and 3x minus 5 into 2. I simply substituted the values. And v square is going to be equal to 2x plus 1 whole square. I'll have to simplify this. Thus, I'll end up with 6x plus 3 for this thing and a minus sign in between. So, to avoid confusion, let's write this like this. So, I'll be left with minus 6x plus 10. Or in other words, you can write this down like this to avoid confusion. The minus sign is outside. And then 2x plus 1 whole square. 6x cancels out on minus 6, leaving 13 in the numerator, and 2x plus 1 whole square in the denominator. This is my final expression for the differential of y after applying the quotient rule. In this case, we weren't given any value of x to substitute or find the exact value of the gradient f. So we'll move on to our second example, 5x plus 1 over root 2x plus 3. We start off by determining our u and v, which are 5x plus 1 and root of 2x plus 3 respectively. Write this down. Write down the root as a power. It just makes things easier. So u prime is going to be 5. V prime is going to be 1 over, just a second, I'll do the whole working for you guys. Bring the power down, reduce the power by 1 into differential of the bracket. 2 and 2 cancels off, thus I'll be left with 1 over root of 2x plus 3. So this is what I have to use, this is what I have to use, and this is what I also have to use. Substitute these values in the formula for the product rule, and thus I have this. We have minus sign, phi x plus 1 is u, and v prime is 1 over 2x minus 2x plus 3, or v square. Don't forget this. V is root of 2x plus 3, and since we have v square, the square cancels off with the square root, leaving us with leaving us with 5 to x plus 3 minus, alright, so we have a 2x plus 3 here too. How about we simplify the numerator first by making this a single fraction? In order to do that, we had 2x plus 3. Let's multiply this by this denominator. So this becomes a square. The numerator becomes a single fraction, leaving minus 5x plus 1 in the numerator. And this denominator, 2x plus 3, since the square cancelled off with the square root, can be written as divided by 2x plus 3. Since whatever comes after the equals to sign, whatever comes after the division sign is reciprocated and is multiplied with the expression, I can write this as this. And this would lead me to my final simplified expression. 10x plus 15 minus 5x plus 1. Did I make a mistake? Yes, I did make a mistake. This would be minus 5x and minus 1, since the minus is outside the bracket. This is a common mistake students make. And I can rewrite the denominator as 2x plus 3. 1 plus half is 3 over 2. Simplifying the numerator, I'll be left with, or let's do this one by one. 10x minus 5x is 5x plus 14. And this is my final answer. And this is where we wrap up quotient rule. Just remember the formula. First of all, determine u and v. Find u, v, and u prime and v prime. Then simply apply the formula v into u prime minus uv prime over v square. V prime u prime, no, v u prime minus uv prime over the whole thing over v square. And this is where we wrap up.